So for our rules, I believe, of course, yeah, every one of us, we're in somewhere that is safe. So we don't have much safety talk. But I think, yeah, just make sure you're in a safe environment. And I think for the meeting, we'll ask you to mute your mics and switch off your camera for better experience. You can rename yourself, use your full name, and you could also add company and affiliation. There'll be a quick Q&A session. So yeah, during the course of the presentation, you could type it out and leave it on the chat, or during the QA session, you could raise your hands and yeah, you'll be asked to ask your question. At the end of this event, there will be a networking session. There you can unmute and switch on your camera. The meeting is recorded, so we would have the recording slides, the recording and possibly the slides after the webinar. So for the agenda, so we've had the welcome and safety talk. I'll be handing you very soon to the chapter coordinator for his address. He's going to introduce the chairman of the technical meeting, then the chairman's address and introduction of the speakers, then presentation by the speaker, Q&A, announcement, vote of thanks, and then the networking session. Thank you so much. Over to you, sir, Dr. Iwobi.
Okay, once again, thank you for logging into this webinar, our first session for this year. I am Dr. Iwobi. I'm the chapter chairman for the UK Europe chapter of NAPE. I'd like to welcome all the attendees. If we have any of our fellows of NAPE who are here, a special welcome to you, and any other member of the NAPE Exco. We're expecting that the NAPE president will join at some stage. I don't know if he has joined yet, but he did promise that he'll be here today. I'd like to welcome all the members of the NAPE family in UK and Europe and across the world. I can see we've got people from different parts of the world as far as Canada. So you're all welcome to this session. Today, we have a very interesting topic, a topic that would exercise the minds of many of us as professionals in the oil and gas industry. It's to do with well interventions and remediation. So I wouldn't want to steal the thunder of the people who are presenting. I'll just go ahead and introduce the chairman for this session. Is Matthew Ibukun, who we just contacted a few days ago, and he accepted to be the chairman for this session. So Matthew, thank you very much for agreeing to chair this session for us. Matthew is the chairman of Argyle IT and Education Limited, which is an educational technology company. For those of us who were here last year, we had a presentation from Obeyemi, who is also part of that organization. Matthew is a geologist with a bachelor's degree from the Ondo State University and a master's degree in petroleum geology from the University of Port Harcourt. He is a very experienced professional with over 30 years experience in the oil and gas industry. He is also the managing director of Borlight Limited, which is a UK company that provides well engineering services to the oil and gas industry. So thank you, Matthew, for accepting this call, and I'll hand over to you to pilot the affairs. Thank you.
Thank you, Dr. Iwobi. Very, very pleased to join you and share this meeting. Before we start, just a quick introduction to the topic we're having today. It's on well remediation using Martwood's continuous customized chemical injection technology. And we've got our able speakers that are here to address that for us. Mr. Uzuazor, Tony, will be doing that for us. He's the co-founder of Martwood Energy Company Limited. He has a HND Petroleum Engineering degree from PTI, and he has worked as well completions field lead in Halliburton for 9 years as a senior completions, or he was senior completion field engineer with SEPCO, and he's here today to do justice to this. But before we start, what is wax? Wax is a problematic issue in the oil and gas industry. It happens during production life of the well, and it occurs when you have temperature that is very, very unconducive, an environment unconducive for oil and gas to flow, and the wax starts crystallizing, and it just forms at the wall of the of the tubing, making flow restriction very, very difficult, and then you have a lot of issue with production of the well. So without much ado, I want to hand it over to Uzuazor Tony to do justice to this, while we use chemical remediation to address the problem of wax in the oil and gas industry. Thank you, Uzo. I believe there's another speaker as well, but maybe he's not here. Okay, that is Ariagbonse Osakpamwan. He's also a co-founder of Martwood Energy Company Limited. He has HND Petroleum Engineering also from PTI, and he's worked with Cisco Nigeria Limited as field supervisor for 15 years. He has intervention experience for 2 years, working with Costa Oilfield Technologies Incorporated, as well as Costa Tech Petroleum and Chemical Solutions Limited, and Ariagbonse Nigeria Limited. So the two of them will do justice to this for us. And at the end of that, we have a question and answer. Please let us have our questions and answer posted in the chat, and we'll address this after the session. Thank you so much. Speakers, please can you do justice to this topic for us?
Okay, good afternoon, everybody.
Good afternoon.
All right, my name is Tony Uzuazor. Like I said, the co-founder, Martwood Energy Company Limited. We welcome everybody, especially to this business meeting. Let me share my screen. Permit me to share my screen, please.
Okay. Go ahead.
Can you see my screen? Yeah.
Yes. It's up.
Okay. Yes. 1 minute, let me put in a better mode. Okay, so before I proceed proper to the discussion, permit me to just take a little few seconds to introduce our technical partners and ourselves here in Nigeria. So please just signify by
Hello, Mr. Tony.
Yes, I can. Can you hear me?
Yes, I don't know if it's from my hand, but we couldn't hear you anymore.
It's better now?
Yeah, I think it's better now. And if you could turn on your
Thank
video,
you.
that would be good. We want. Yeah.
Oh, okay. All right. It's okay, right?
Yes, perfect.
All right. Okay. I'll just find a way to take this away. All right. Okay. So I was saying a little bit of introduction from our guys here. So we have Andrew. Andrew, I think, is having network challenges. Okay. Andrew is having network challenges, but when he comes
Andrew
up,
is connected.
I'm on
okay,
now.
it's connected now. All right. Okay. Okay. So we have Andrew as a co-founder, and he's also going to speak to us too after this section. We have Martins. I think if he's when he comes up, I think he can. Then so we have Dr. John. Dr. John Anthony is the MD from Bento Nigeria Limited. Is with us as a research and development analyst. I don't think he's on, but we're expecting him. So over to our guys in US, we have a technical partner in US. We have Mr. Shegun Olowo Kere. I've seen him on. Mr. Shegun, you on? Mr. Shegun, I think I've seen him on the call. We
Yes,
have
he's on.
Mr. Mr. Adetoro Oyadeyi and Mr. Damian Ifetubore. Three of them work as our technical partner under Rehoboth International Services Limited. So our technical lab in the US, they handle the laboratory of the waxy crude. Okay, having said that, let's go straight to, sorry, please. All right. Okay, paper presentation on wax remediation using Martwood's continuous customized chemical injection technology, of course, by me, Martwood Energy. Okay, just a little bit about the company. Martwood Energy Company Limited is an indigenous company incorporated under the laws of the Federal Republic of Nigeria with a team of qualified and seasoned professionals and consultants with years of experience in the oil and gas industry. Our commitment lies in meeting the set goals of our clients by maximizing crude oil production with our advanced technology. We recognize the importance of good corporate governance and are dedicated to providing safe and efficient service delivery to our clients. At Martwood Energy, we believe that each job we undertake should be as good as our last, driving us to deliver excellence consistently. Our services range from wax remediation to well completions, slickline services, pumping services, coil tubing for now, and others that we want to mention. Just leave it as etc. Okay. Yeah. Okay. So abstract. I wrote here, I think Doctor have done justice to what wax is. So just take it from here. Abstract. There are three known methods of treating crude oil wax: the mechanical, thermal, and the chemical. In mechanical methods, wax deposits are scraped out by paraffin cutter, just like using slick line, slick line to drift. For those who are familiar with well completions, drifting, your tubing is similar to paraffin cutting. Whereas in thermal heat method, heat is applied to melt the wax deposit. Now, in the thermal method, it's either hot oil is poured directly into the well, into the tubing, or hot water is poured into the annulus between the casing and tubing, okay, to melt the wax deposits. Mechanical methods may cause perforation plugging. That's one disadvantage of using slick line. While this thermal process I just explained, may be responsible for permeability damage. You agree with me that both methods cannot modify or does not. Can I go ahead? Somebody was echoing. Can you hear me?
Yes, you can go ahead. Go ahead.
All right. Okay. So both methods do not modify the chemical properties of the crude oil, and therefore cannot prevent further wax deposition. So that is why we don't encourage the use of just both methods, because they do not modify. Now, chemical methods use customized chemicals to alter the chemistry of the crude oil or slow down the rate of deposition by preventing agglomeration and cluster formation. Hence, the best method of treating wax is by carefully studying the crude oil sample and subjecting through rigorous laboratory analysis to come up with a customized blend for wax remediation, which is what we do. Okay, so we don't just pour in our chemical, we do a lot of laboratory analysis on the crude sample to come out with a blend to treat the waxy well. So for introduction, I wrote here, crude oil wax is common to the oil industry, and each year a lot is burnt on manpower and the resources to curb it. Waxy crude presents significant problems and challenges during production, processing, storage, and transportation, which in turn affects profitability. The high pour point viscosity and wax appearance often result in pipeline blockage, pump failures, and increased operating costs. To mitigate these problems, we propose the use of continuous chemical customized injection treatment program for the prevention and removal of oil wax in our wells. Our chemical treatment approach has been designed to improve the flow properties of waxy crude, simplify processing, reduce the risk of pipeline blockages, and increase productivity. Our chemical treatment process is cost-effective, is efficient, and we guarantee that it will help improve the quality of your crude oil. Now, this guarantee we're going to see when Andrew comes up with our case study. You're going to see what we're talking about when we say we guarantee quality of crude and quantity also. We have carried out extensive research and development, and our team of experts, which include petroleum engineers, flow assurance specialists, artificial lift advisors, expert chemists, and consultants, have years of experience working with waxy crude. Now, let me say this here also. So what we do is not just based on wax alone. Okay, so there are so many wells in Nigeria that the crude is termed heavy crude there. So our system of operation, our technology also addresses that, whether you have a heavy crude that is difficult to flow or just wax or paraffin and the rest of them. So it's still the same process and the same system. Methodology. So I wrote here how we do it. That is what this is about. The methods we use. Sample collection. First, the waxy crude sample is taken from the wellhead or during drilling. Now, two ways we can take samples, either from the wellhead or during drilling. In drilling phase, during the drilling phase of the well could be maybe when you stop for DST operation, just something similar to core taking core samples during drilling. So we can have the crude oil there, the sample of the crude oil there. We'll take it and subject it to a laboratory analysis. Taking sample during drilling gets us involved in the design phase. Now, what this does is, most of the wells we're going to talk about today or something are already drilled and completed. So nothing can be done except you want to pull out of hole and redesign. But when the well has not been completed, there, once we identify that is a wax producing well, we can quickly come in the completion phase to impute one or two completion jewelries that could help us easily mitigate wax. So that's what it is. So the first thing here is to collect sample. We'll take a sample, whether from the drilling phase or whether it's already completed, flowing well. We take a sample and then we send to our lab. Laboratory analysis number 2. The crude sample is sent to a laboratory in the US for rigorous study and analysis. 3. Chemical treatment phase. A customized chemical is produced and formulated based on the results of the laboratory analysis for injection through customized kit. Our team of experts, well completion, of course, I did well completion, and Andrew too, and others. We have other people on the call too who are with us, completion intervention experts, design a safe and efficient method to continuously inject the chemical into the tubing string based on the completion jewelries downhole through our surface mounted skid. So what this means is that we have a skid mounted on surface like a pump that's like a dose when we have decided which best method to use to deploy the injection process. The surface mounted skid gives like a dose through whichever channel we decide to inject from. Well monitoring phase. Production rate is monitored to ascertain effectiveness of custom chemical. the benefits of customized chemical. One, cost reduction. I know there's going to be a lot of question on cost, because I know people have their various ways of doing this. One will come to that anyway. We have proof of that it is cost effective. So on the long run, I wrote here, increased flow efficiency will lead to reduced energy consumption and maintenance costs associated with mechanical cutting and heating and insulation systems. Also, by maintaining fluidity, expensive mechanical interventions like pigging is minimized. So a lot is going to be like taken away from your cost of running your operation by the time we successfully install our system. Two, enhanced flow efficiency. By treating the wax and altering the biological properties of the crude, the proposed chemical treatment program will improve flow efficiency, limiting operational interruptions and further reduce non-productivity. Okay. Thirdly, improve product quality. The customized chemical treatments will ensure the production of high-quality crude oil, minimizing the presence of contaminants and impurities commonly associated with waxy crude. This will positively impact downstream processes and increase the value of the final refined product. Other benefits are listed below as capacity to dissolve the organic deposits, prevents gelling of oil in cold climates, acts as a good corrosion inhibitor, prevents wax agglomeration, makes heavy or viscous crude flow, I've said this before, make it difficult for the precipitated wax to stick to the wall, has the ability to coat and create a surface film on the internal diameter and the outer diameter of the production tubing, thereby making it difficult for wax deposition to adhere to the wall of the tubing. So in conclusion, I decided to make it so brief so that Andrew can come up and then we discuss, because it's supposed to be an interactive section where we ask all the questions and then we provide some answers as best to our knowledge. Conclusion. We believe that the best way to deal with wax, paraffin, aspartame, etc. problems is to prevent them where possible. To mitigate the formation of wax, paraffin, and emulsion, etc. problems, chemical injection lines have to be introduced from the design phase, thereby mitigating the cost of workover operation, wax cutting, and solvent soak. Chemical treatment of waxy crude offers an effective and sustainable solution to mitigate the challenges associated with wax precipitation during oil production and transportation. The proposed chemical treatment program, supported by laboratory analysis, pilot testing, and ongoing monitoring, promises to enhance flow efficiency, reduce costs, and improve product quality. As we said before, a sample of the waxy crude oil is taken from the wellhead or during drilling phase, sent for laboratory analysis, and a custom blended chemical is developed for the crude for the problem. So this is just a brief of it. I believe when we start asking questions and then we'll talk furthermore of even areas that are not touched. But the whole idea is this. You have a waxy well, we'll take a sample of the crude, we'll send to our lab. Based on the result of the lab analysis, we'll come up with a customized chemical that
It seems we are losing your network there. We are not hearing you very well, Mr. Uzuazor. Okay, I think Mr. Uzuazor has completed his presentation concerning the remediation of wax in the oil and gas industry using, that method which he has highlighted the use of chemical, injection into the wellbore. We want to have some section now of Q&A. And I wonder if during this presentation, any one of us that has listened carefully to the presentation has gotten questions and answers, questions that, he or she want to pose to the presenters for this meeting. Can we have such questions? Or Tony, do you still want to say something?
Okay, I think my network was shaky, but it's okay. So
Yes.
I believe everybody you heard the conclusion part of it, the concluding part of it. I believe I did that, right?
Yes.
Okay. So let me
Very
just
shaky
stop
to
there
the end,
for
bro.
Andrew to continue. Andrew, yeah, okay. Andrew will take over for the case study. We have where we've worked on before. So let him use that to further buttress. Then we'll take questions and answers, and then we'll give answers. Thank you.
Great.
So
Thank
after
you.
Andrew finishes, then we'll take questions. So our guys are also online waiting. All right.
All right. Thank you. Over to you, Andrew.
Andrew, you could unmute.
Okay. Good
And
afternoon.
yeah,
Good afternoon, all.
Yeah, good afternoon. And please turn on your video.
Good afternoon.
Okay. Okay, can you see me now?
Yes.
Okay, I'm on the rig actually
Okay.
right now. And so mind my surrounding for now. However, please permit me to share my screen, so we can proceed with this presentation. Can you all see my screen?
Yes.
Yes, we can see you.
Okay. So, as we all know, wax, paraffin, aspartame, all these problems are not strange to us. They are very old, and we can tell. So it is good we use a new technology to be able to address or to mitigate this very old problem. And you all can attest to that. So in Martwood, we believe that in dealing with wax problem, it is best you prevent it before forming, forming to disturb the operations or flow assurance. I will be diving in the course of this presentation. I will be diving briefly into the history of this well. Very brief. So the well we did, like Uzuazor rightly mentioned, where X was completed as a dual well, completed well, with has three zones, one AB4 on the short string, the other reservoir 3AB4 and 5AB4 on the long string too. So 3AB4 and 5AB4 are on the long string. Now, according to the available data we have on the completion, the one AB4 is at the topper or at the upper section. Moving forward, this well has experienced wax over the years, and this has affected their production rate to the point that it dropped to 100 barrels produced per day. You can imagine. And the GOR to 310, all of these are in June 2013. For a while, this well was shut down. Then subsequently, at interval, it was reopened again. This our client has done series of WAS remediation with different clients before. They had margin, a success margin. But then the well was from 100 barrel production per day, it now went to 530 barrel production per day, and on choke 2864. So the well was later placed on continuous chemical WAS cutting operation. And that period, that decision made them to be able to have a slight increase in their production rate from 500 to 768 barrel production per day, still on that choke 18, with basic sediment, to 900, with basic sediment and water of 60%. Then the fluent tube head pressure of 220 psi, and the being the choke is on 26/18. Till now, the well had been producing wax after that time. So at a point, they had to shorten the well, coming back again until that's how the trend. The production of the well later fall down to way below even 600 barrels of oil production per day. As you can see, this is the tree of the said well X that we did work on. Now, if you look this tree carefully, I took the back and the front picture. If you look the picture on your left rather, you can see this arm is the short string. The other arm on the right is the right string. Now, moving forward, the long string, which is the 5AB4, wasn't at a point stopped production, it dried up. And the other reservoir, which is the 3AB4, was being tapped into by a different
Andrew, I think we've lost you.
By a different, we got to the
Sorry, Andrew, we lost you for a few minutes, please. Could you?
Okay.
Lost you briefly.
Okay. So this, look, let me go back a bit. I said this tree we are seeing now is the well X we worked on. As you can see, the arm on your left is the short string, and the arm on your right is on the right string, on the long string. Now, the long string stopped producing crude, stopped producing dried up. Then the other aquifer, the other productive zone, there is another well that is tapping on that well. So it is not in use in this configuration or in this well. You get. Now, moving forward, as at the point we did WAS remediation on this well, we install our parameters on this well, our device on this well. We are able to deduce the production per day on the short string, which is the 1AB4 that is being in use, that had WAT issues. So the 1AB4, when we install our device, we are able to discover that the production per day was no longer 920 anymore, but now dropped to 620 barrel of oil, produced per day. Now, this is the schematic of the well that I was trying to explain to you. Now, if you look the schematic very well, you can see the short string, which is being produced from the 1AB4. You see the 1AB4 has a screen. That's where it's being produced from the short string. Then the 3AB4 it's not, like I said, it's not being produced via this well. It is being sucked, it's being drained from a different well. Now, the third one is this 5AB4 that has that dried up. Now, one of the challenges we were able to mitigate was that not being able to solve this well, not being able to solve the wax as it is, but we were able to deduce the way in which we are able to mitigate or to treat this well, because there is no chemical injection line on the well. As you can see this schematic, it is an old well. There's no chemical there's no schematic on this well, no chemical injection line on this well. So what we did was that we were able to use this long string that's no longer in use. We plugged off, we have two barriers that we did install. We plugged off we plugged off using our plug and prone to plug off the bottom, and also install our selective tool to plug off from the SSD. So we have two barriers that we are able to install. Now, from that place, from the long string, we'll now use the long string as our chemical injection point, thereby dosing our chemical through that point and treating the well, or the well. Now, this is work in progress. Now, you can see that on this field, we did not use coil tubing at all. We were able to reduce the cost and also achieved our main objective, which is treating the well. We use slick line, as you can see. Here's my mouse. You can see this aspect now is the chemical injection skid that we built, and this area is where, or this place is where the client attempted to use through chemical and through injectivity on the flow line, but still to no avail. As at the point we did this job, on the valve very close to this injection point that the client did, we still found huge wax deposit. When we broke some of the valves that was there, we found huge wax deposit. So moving forward, because of time, so we treat the well using our chemical. We were able to get a sample of this well, send it to our lab analysts, our lab technicians. They did a fine job by studying the well and come up with a custom blend. Now, when they come with that custom blend that was peculiar to this particular reservoir, to the particular well, this crude or the wax, we were able to achieve a very spectacular result. Now, what was the result? The client was able to, as per the production they had initially was 620. As a result of our treatment and our continuous chemical injection skid, we were able to, after we treat the well, the well was able to produce over 2,150 barrels per day. You can on choke 18. The well was ever since was on choke 28. Now you can imagine now from choke 28, reducing it down to choke 18. That's one. Number two, you can imagine now if the client decides to go up a little bit, we all know what will happen to the production. Certainly, that's what we all need in our fields. You get so continuous ejection. If you see the arm, the long string now, which is on the right-hand side now, you are able, since there is no chemical injection line on the well, we are able to decipher using the long string now as our chemical injection line. Now, we took off the arm of that, install the valve, and install the custom blend, the customized skid that was designed peculiarly for this well. You can see, let me see if I can zoom a bit into this. Okay, can you all see it, please?
You can
Yes, we can
see.
see you.
Okay. Now, if you look at this well now, we are able to look at our flow line that we use as this control line. That's where we use as our injection point, straight down into the reservoir and treating the fluid, altering the geno of the fluid to mitigate wax deposition or wax formation. Now, moving forward, this is myself and one of my colleagues too. This particular skid is an electric skid. It is custom designed to the client's needs. They requested an electric skid. Now, what we equally did was that on this skid, the pump, we had a backup system, which is we provided them with 2 different pumps. One. Number 2 is that you don't depend on NEPA to provide light to power the skid. We mounted solar and equally a diesel generator there. Now, the skid was designed with some safety features. What are the features that was embedded in the skid? Now, we were able to put a check valve, not just one, not just 2. We had check valve on the system that were able to withstand 8,000 psi to the range of to 10,000 psi. So there is no issue of backflow. There's no issue of the well coming back on us or coming to the skid. No, it's well taken off. Now, or there's an issue of the issue of the skid pumping too much pressure on the line. We had a pressure control device that we installed too, that we reduce the pressure. Number 3 is that this skid is
Andrew, we
dynamic.
can't hear you. We can't hear you anymore. I think your network is there.
Oh.
I think
we
we
can.
are hearing him here.
I think it's your network.
Yeah.
Okay. This skid, it's a dynamic skid. It has dual pumps. You can calibrate it to whatever flow rate you want it to be. You get it has on the tank, we have a vent too, so that when sucking sucking through the pump is on suction, it does not collapse the tank itself, and other very, very wonderful benefits. This is myself and my colleague here. We are loading chemicals, as you can see, on the 2 tanks that are there. This is on this screen, on the screen now, you can see us putting on this barricade to prevent sabotage of the equipment, and also sabotaging the fine work that we did on this particular asset. So let me go back on this particular asset. So once again, getting a sample from our client, we do a detailed or a rigorous study on the wax on the crude oil sample that we get, and also coming up with a custom blended chemical for that well, and also providing a custom skid that will be able to mitigate whatever challenges that our skid may find in whatever respective atmosphere that we present, or challenges that the skid will face. So at this point, I will rest my case so that we'll accept questions and questions from the audience. Thank you.
Thank you, Tony and Andrew. for those two fantastic presentations. From this, we could see and hear and realize that wax is it's problematic in the oil and gas industry, and you have chosen to be able to look into this and continuously mitigate the formation of wax in the oil and gas industry. Thank you for the introduction and the methodologies that you have used to look into this and highlighting the benefits as well for the oil and gas industry. For the case study that we have just heard from Andrew, he has made it clear that the method of chemical, continuous injection into the well has given a good dividends, has given fantastic benefits to the client, moving production from 100 barrels per day up to 2,150 barrels per day. That is enormous. And yeah, it looks more like that is working very well. So we want to just go ahead now and take question and answers. Please, if you have your question and answer, your questions, please put it in the Q&A section, and we are going to look into it. We have able presenters that will help us to analyze and give answers to your questions. So without much ado, we want to just quickly go into Q&A section now. And the first one that we want our panelists, Andrew and Tony, to answer, as well as Shegun Olokere, if he's able to answer where he is. The first one has to do with how much does a typical dewaxing batch operation cost? How much does a typical dewaxing batch operation cost?
Okay, Andrew, do you want to take that, or I should go ahead?
Okay, go ahead. Go ahead.
Okay, we can't pinpoint, say, okay, we can give an swamp wells, we have land wells. Okay, so the cost for a land operation, a land job, is quite different from a riverine, deep sea, shallow sea, or swamp operation because of the other accessories you are going to use. Okay, but if you want just an estimate, let's say from okay, when you say wax operation, so we are subjecting it to just this chemical, what we are discussing here, okay, not mechanical, not thermal, just what we are discussing is here. So for an estimate, though I'm not 100% correct, but we are looking at over $500,000.
Okay.
Yeah.
Thank you. Maybe what we can do next time is to just show our videos for us. Yeah, please. Okay, the next one coming from Toye Lolo it has to do with this one, practically from your experience. What other benefits or beneficial uses can the dewaxed paraffins in such a chemical treatment process be channeled? That means, which other way can you channel the waxed paraffins that you get from, these oil wells?
Okay. Let me take that.
Okay.
I think one of the things we can do is first to having to see your site inspection. We need to see your site. We need to see your schematic, well schematic. We equally need to get detailed information of your well, so we can be able to come up with a way in which we can be able to treat wells or to mitigate them. So we need information too from you.
Okay. He's saying, what other beneficial use can the dewaxed paraffin be channeled? different from having, or collecting data from them. But what you use the wax paraffin be channeled once you have, treated it chemically.
Okay, I think Mr. Shegun, I think you can come up here, or Mr. Adetoro, you can throw more light on this. But for us, what we are interested in when we send the crude sample to the lab, what we are interested in is the aftermath of the end product of that process, giving us a customized chemical that will be injected into the well. Now, when the chemical is injected into the well, wax do not form anymore. Okay,
That's right.
So except he's asking that the sample that we took to the lab, if you dewax it, because you can extract wax from that sample. If that is what he's asking, what can you do with it? Well, it is not really concerned about. We're not really concerned about that. Okay, what we are concerned about is getting the chemical, which is the end product, and then inject into the well. When we inject into the well, there is no more wax formation. So we can't say we want to get wax anymore. I don't know if that answers your question. However, Mr. Shegun can also throw more light on this if he wishes to.
Yes, his hand is up already, so please
Okay,
go for it.
Go ahead.
Yeah, can you hear me?
Yes, please.
Yeah, good afternoon, everybody. But here is more. But what the guy is talking about is about what other benefit is the wax from the crude. That is for the upstream. We are talking about downstream. In the refinery, the wax crude can be used for so many things. They can use it for pomade. We have paraffin wax. So many things. You can use it for candle. So many things can still be used. But what we are saying now is trying not to allow this wax to form in the well held or in the flow line so that it can be shipped to the refinery. And from there, after fractional distillation, the heavy paraffin wax can be used, which is more or less a raw material for another sub-company. They can use it to blend so many things. So that's the other usage that this wax can be used. But the actual goal is to not allow wax to form so that there will be easy transportation of this to the refinery. I hope I've answered your question.
Yes, I think that is a fantastic answer there. Another one is what's the chemical composition of the chemical injected into the reservoir, and how environmentally friendly is it?
Okay. I would like to take it, please.
Okay, go ahead.
Yeah, when we talk about chemical being injected to the well, there are a lot of chemistry that goes into it. The chemical we blend contain 3 types of chemicals. One, we call it a crystallization modifier. That one will not allow the crystals to form at all. What we normally, when you allow crystals to form, they form a long chain and come together, and then they precipitated. That causes the blocking of the tubes, and also make the viscosity to increase, the fluidities reduce, and then the production shorten. So the chemical we use, the first thing is we modify these crystals. We call it crystal modifier. And I don't want to belabor you with the actual chemistry behind it, but what we do is just to make sure that those particles or the crystal particles of this paraffin could not come together. Then we have another thing called the dispersant. It's like a detergent. Make sure truly these crystals are not coming together, but we make them to be equally distributed within the crude so that they will not just be hanging one somewhere. So they are easily dispersed so that when you are pumping or when it's being flowed, it goes quickly. Then the third one that we have what we call stabilizing agent that we have to eat. so that this chemical, when they combine inside the solvent, and the solvent we choose is different. I mean, there are a lot of characteristics in the type of solvent we use. Truly, on the environmental aspect, we try to use a chemical that is compatible to the crude. Majority of people, they use what they call hot saline, but saline is carcinogenic. People are moving away from saline. But we have heavy hydrocarbon like naphtha, like all that type of solvent that we use. So we put the environmental aspect into consideration. And the advantage of using chemical also, I mean, using blended chemical is that it reduces actually the temperature that you need to pump the chemical. And we are talking about how this chemical also can be injected. We've been talking about the best thing is to inject it before the wax is formed. So that's why we are so partnered with Martwood. They know about the well completion. They know the zone. They will have to know the temperature profile. Want to inject before the cloud point, and so many things. But if it's a new well, we need a crude Harley so that we can do what we call the wax appearance temperature test. We can do the profile. We will know the right place to feed it. But I think I need to stop there. So I don't know whether I've answered the guy's question correctly.
Thank you so much for that answer. I want to move quickly forward because of our time. This question is coming from someone too. It says, very interesting presentation. What is the impact of the chemicals you use on the reservoir in terms of potential formation damage? Does your workflow take into account the geological property of the reservoir?
I will answer also, please, if you don't mind.
Okay.
The chemical we use is hydrocarbon base. Number one, it has no impact on the formation. So it dissolves in the crude. The solvent we use hydrocarbon. The crude is hydrocarbon. So there's no special damage that it will cause. It's just blending into the crude. And it changed the characteristics of the crude by making sure those crystals at low, the paraffin that tried to crystallize out at low temperature could not be able to do it. So it has no impact on the formation.
Okay. Thank you very much for that. We have very, very little time for us to complete this. From the introduction given by Tony the last time, he mentioned that collection of sample is from the wellhead as well as from during drilling. I want him to just tell us which kind of drilling. Is it initial drilling of the well while the casings are being put in place, or other drilling activity going on after the production casing has been fixed and the whole thing is producing? Yes, please, Tony.
Yeah, okay. Two ways, like we said, okay. One, after the well has been drilled for old wells, okay. Let's say you have already drilled and completed well now. We can take crude oil sample from the wellhead. Okay, there's a special way we can take crude oil sample from the wellhead. Now, the reason why we say we would like to take samples during drilling is because by then the well is not completed, okay. It's still barefooted or something, okay. So if we have to take sample for that, if the crude oil has wax potential, we can be able to say, okay, let us inculcate so and so jewelries to the completion so that it will be easier to inject into it. That's the reason. Then during drilling, while you are drilling, there could be oil shows, right? You agree with me, petroleum engineering. There could be oil shows during drilling. That is what we are talking about. Even I think DST can also do that, drill stem test. I think you can also do that. So any way we can get crude sample while drilling before you complete the well, before you put all your jewelries and use the well to surface.
Yeah. Okay.
Yes, that is what we mean.
Thank you very much for that.
I don't know if that's, I think that's good. Yeah.
Yeah.
I just want to add something to it, please, if you don't mind.
Go ahead.
Okay. In addition to what Tony said, the chemical, the sample we collect must be unadulterated. What do I mean by that is, if you see some wellhead like this one, like the picture I showed, you see there is an injection port where they inject they inject chemical through via the flow line. Now, you don't bring a sample after the injection point because that crude has been contaminated already. So what we prefer working with is getting it directly from the flow from the wellhead, whereby it has no business with whatever chemical that is being injected into it.
Thank you very much. Somebody is asking if there is any how do you prevent further wax formation after the waxing? We are talking about continuous dewaxing here. From that case study, that question is taken care of. Also, typically, what is the volume of chemical injected daily to achieve effective wax treatment? That's a question. Can we just quickly answer that? We have just a few minutes to go, maybe 2 minutes now to go.
Okay, let me take that.
Yeah.
The skid is calibrated. You can calibrate the skid to give you whatever whatever result you want, the output of it. Now, it can, whether it's 20 liters or 30 liters, it can give to you, depending on how you want it.
Yeah.
You get, and also depend on the information we get from our own lab analysis, so we can precisely set it there.
Great, thank you very much. The last question we want to take is a very important question, which has to do with the way you introduce chemical into a single well completion without a means of injection mandrel, incorporated in the well initially.
So, do you want to take it or I should go ahead? Okay, let me go ahead.
Sorry, I didn't hear that. I didn't get the full question.
Okay, what I said is that how do you introduce chemical into a single well completion without a means of injection mandrel incorporated in the well at the initial completion?
Yeah. All right. So good question. Right. So depending on the jewelry available, okay, we don't have chemical injection valve, chemical injection line on the well. That's fine. So what do we have on the well? If we have SSD, we can open the SSD, just like the well X, the case study we saw. We open the SSD, and from the SSD we are injecting it to the well. If there is no SSD and we have GLM, gas lift mandrel, okay, that has dummy, we can retrieve a dummy, okay, and either leave it that way, okay, when you remove the dummy, you have holes there, we can inject from that holes, or we have the specialized type of gas injection valve that type of valve, and that valve can open and close depending on what we set it to. Okay, so we have this special type of valve that can replace the dummy in your GLM, and then we can use that to inject. Now,
still communication problem. Okay, I think we want to cut the curtain here. Looks more like we have lost him. The network is not okay there. So I will just pass you over now to Okpeyemi to conclude this meeting. Thank you very much. Thank you, everyone.
Thank you so much, sir. Thank you, the presenters, and also to the other members of the panelists that have helped in answering a lot of the questions. So before we would hand over, get vote of thanks, and of course, speech from the NAPI president. So we have the NAPI president in our midst, as well as the president-elect. And we also have, I think maybe, yeah, what we do is maybe we give them the opportunity first before we go into the announcement. So first would call the NAPI president to address us. And after that, yeah, the president-elect also could also address us too. So over to you, sir. Mr. Abiodun Ogujobi F. Nape. You're welcome, sir.
Hello. Please confirm if you can hear me.
Yes, sir, we can.
Okay, so let me say good afternoon, good evening, good morning, depending on the part of the world that you are dialing in. My apology that I had to join in after the commencement of the presentation. Actually, I was struggling with connectivity, but thank God I was able to join. So I would like to say thank you to the chapter executive for keeping the flag flying. This is one of the things that we do in NAPE. I mean, creating platform for knowledge sharing and best practices sharing. So this is one of the things that we do, and we pride ourselves in giving opportunity to our members to exchange knowledge and ideas. And I think the section this afternoon has been very interesting. Wax formation is something that is common to some of our wells within the delta, and ability to keep the wax it beats the work from forming is actually something that every production engineer or production technologist will be happy to learn about. So, as we normally do, we continue to do this, provide opportunities for knowledge sharing, and I think that is one of the core values of NAPE. So, I would want to thank the presenter and also the co-presenter because I could see that so many people were attending to the quick Q&A. So I want to thank everybody for this session. So all I can say now is that we should look forward to more of this kind of section from NAPE, both from UK, Europe, and from other chapters. I think the network has made us a global village. So any part of the world where you are, you can always log in. And NAPE is trying to bring some innovation and creativities to the way we connect with members. So look forward for more membership benefits. We are going to, especially with regards to our website, we are going to start seeing some changes that will be coming from NAPE as kind of benefit to the members. So look forward to it, and also don't forget that the November conference is always our key conference. And let me also assure the UK Europe that one of these days I will be with you physically in Europe. So if you are going to be in EAG, I'm coming to EAG, so we can also connect at EAG. So thank you very much, and do have a wonderful day.
Thank you so much, sir. Thank you so much, sir.
Thank you, President, for making our time to attend this meeting. We are sure that you will be behind us in all our programs for the year. We are planning a number of activities this year, including the technical sessions, and as we discussed earlier, the EAGE, as well as we're planning to have a one-day out at the British Museum with our members and the families in the early summer. So we'll keep you abreast of all our plans for the year. And thank you so much for
Thank you.
sorry, please, I'll have to leave now. I have a train to catch.
Okay. So could
So,
you quickly
thank you
give
very
us,
much.
maybe you could give us vote of thanks before you leave, if possible, and then we just continue from there. So
Okay, so sorry about that. I have to leave now,
Yeah.
but I'd like to thank the presenters for doing a fantastic job. This presentation, it's very interesting, and we know that the financial implications of lost production because of things like wax problems and so on and so forth. We're geoscientists primarily, but this is a very good interface between the engineers and the geologists. So thank you very much to Mart Energy for the presentation, and we hope that we'll see you again at future presentations. So thank you very much, Tony and Andrew and the rest of your team. And to all the NAPE executive who are here, I understand that the president-elect is here, John Bosco, the president himself, and some other members of the NAPE Exco. So thank you very much for making our time to be with us. So I'll have to leave now, and I hope the rest of the session goes very well. Thank you very much, and God bless.
Thank you so much, sir. Yeah, and right now we'll just ask Mr. John Bosco Oche, the president, FNAPE, the president-elect, to give us his address.
No, thank you very much, Opeyemi, and always exciting to join the Europe UK chapter. As some of you will know, I was part of you at the beginning as one of the pioneer members. So exciting to see this continue to happen. So it's been a long afternoon, so I wouldn't say much. I mean, we've heard the president speak, and then again, the chapter coordinator himself. So it's just to add my voice to everybody still on the call to say really thank you for, again, both our sponsors and presenters, Martwood, and then all the other members that have joined. I also see one fellow also. I think I saw Wilson also, who is a fellow of NAPE on the call as well, and then a few other members. So let's continue to connect to our technical meeting. I think that's the heartbeat of NAPE, and that's what we do. So UK Euro chapter, all other chapters doing the same thing at Lagos national level, doing the same thing, so that the knowledge base that we have to continue to use our platform to share that knowledge. And I think that's exactly what UK Europe chapter is doing. Again, very good topic around technology. So, we do geology, subsurface, technology, business. Let's bring all the knowledge we've got, put it on the table for us to share that learning. So I really want to say and encourage the executives and the ESCO of UK doing quite well. And be rest assured that from my side as the president-elect, and chairing the continuing education program, I will continue to give my support as much as you need it. And again, like the president mentioned, let's continue to build up the momentum as we head towards our conference in November. We just only yesterday inaugurated the conference planning committee. So the work is already on. So technical papers from UK Europe chapter, let's already begin to articulate what we want to show at that conference. So without saying much, so let me hand back to you and say thank you very much. And I'm excited that I have a chance and an opportunity to join the session this afternoon. Yeah, back to you.
Thank you so much. Thank you. Yeah. Of course, yeah, you're always part of us. I know we've just loaned you briefly to Lagos, but yeah,
no worries.
good to have you. So yeah, we just quickly run through the announcement that we have. I think as it has been said, we have typically technical and business meetings. And so for this month, before we go into this month, I think, we want to look at the technical meetings that will be hosted by the Lagos chapter, which is the main body. So the one coming up next, that's application of customized permeability and saturation height function model to fields in Niger Delta. That will take place on the 6th of March at 11 a.m. This is in honor of Mr. KK Kano, FNAPE, who most times attends the UK chapter meeting. So he's a friend of the UK chapter. So 6th of March. So you can save the date. And then the next one is capturing the future, the geology and geophysics of carbon storage. That will take place on the 17th of April at 11 a.m. Echo Hotel and Suite is still the venue. So please take note of that. And then for other chapters, Aqua Owerri chapter, they're having a technical business meeting this month. The title is The Multivariate Nature of Geosciences and How You Can Build Lasting Impact. The speaker is a one-time publicity secretary, Mrs. Tubosun Afolanya. And the date is 29th of February at 11 a.m. So you can join using the link that we have here. Is both a registration link and also the link that you can use to join the meeting. We have a new chapter outside of Nigeria called the North American chapter. They've been inaugurated, I believe so. They've been inaugurated, and this is their first technical business meeting, and the title is on Linear Opportunities in Nigeria's Rapidly Evolving Energy Landscape. The date is 21st March 2024. We're glad to have a lot of our sponsors. We really appreciate the sponsors that make these programs possible. And we have another one by the Port Harcourt chapter. It's titled Unlocking Exploration and Development Opportunities in Deep Water Nigeria Using Regional Geology and High-End Geophysical Tools. The date for that is 26th of March, 11 a.m. at the Royal Banquet Hall, Hotel Presidential, Port Harcourt. And you can also join this event online. So that's our technical meetings. This year, of course, as part of the oil industry, we also exhibit at NAPE as an organization exhibits at different conferences. So we're exhibiting currently at the Nigeria International Energy Summit that ends on the 1st of March. So if you happen to be in Abuja for this particular summit, please, you could stop by at our booth. The booth number is booth B47. This year, we would be having our annual international conference and exhibition with the theme Resolving the Nigerian Energy Trilemma: Energy Security, Sustainable Growth, and Affordability. The date is the 10th to 14th November. Venue is Echo Hotel, Lagos, Nigeria. So please take note of that. And there are various sponsorship opportunities, as well as the call for abstract is open. As we've been told, you could write a paper and submit. So for the exhibition opportunities, so that is open. I think for companies looking at sponsoring, this is exhibiting. This is cost effective. It's around 90,000 naira per square meters. So if you're interested, you can contact. We have the details here. Mrs. Abidemi Belgor. These are her details, and you can contact her. So we always, of course, for us to enjoy these benefits, it's active members that consistently pay their dues that make this possible. And so we're always encouraged to do so. And as a company, you could also register. So you can register your company, and the annual membership fee, it's affordable. So I think we are encouraged to pay our dues, and you can pay into the account that we have here. So for technical meetings, if you have a paper you want to present at one of our technical meetings, you could contact Mr. John Bosco. For UK, you could speak with me, or you can speak with Dr. Iwobi for that. For UK opportunities. So that's it for us. Thank you so much. We really appreciate your presence, before we leave, we have Mr. Gideon Giwa. I don't know if he's left, who was our chapter coordinator here before. So it's good to have you, sir. Thank you so much for coming. And yeah, that is our meeting. And yeah, it's open to networking, so we can network. And then yeah, so we can network. You can turn on your video now and turn on your use your mic and speak. I don't know if Mr. Gideon Giwa wants to say anything, but that's our meeting. Yeah, closed since our coordinator has given us the vote of thanks. Thank you so much for attending. We really appreciate your presence, and thank you for the speakers for a wonderful presentation, and for everyone for the question and making it interactive. We really appreciate your presence.
Thank you, Ibukun, and thanks to the team as well. Lovely presentation. Thank you for hosting.
Thank you, sir. Thank you.
Hello, Mr. Giwa.
Good afternoon, sir. Good to see you again.
Thank you very much.
Yes, sir.
Yeah.
I like your location. Or are you in Hawaii somewhere? Or...
Yeah, I can be anywhere at any point in time. Just have a button.
Please take us along next time.
Yeah, thanks.
Brother Giwa, it's a long time.
Hey, long time. I can't see we speaking.